Today we are going to discuss most interesting topic. By understanding this concept, we are going to solve problems very easily in the chapter refraction of light at curved surfaces. And now let us consider this is convex lens. This is the object, and if any line that is drawn parallel to principal axis, that will be passing to the focus, and as a result the image will be formed here. Now we already know that the distance between lens, let it be O dash is the object. The distance between lens and object is nothing but u. It is the object distance, and the distance between lens and the image is nothing but v. This is the image distance. Now you see here few examples I would like to say you. Here is the object and image is formed here. The light ray is traveling in this direction, and we are measuring the object distance from here. That means the ray is going in one direction and the object distance is taken in another direction. In this case, u is negative. In this case, u is negative. The ray is going in one direction and the object distance is taken in the other direction. Hence, we should consider u as negative. That means the object distance is considered as negative. You see, in this case, the ray is going in this direction. The image is also formed in the same direction. Hence, we should consider the image as positive, and here it is taken as v. And I already told you that when we consider a lens like this, if you want to draw center of curvature, we have to extend the circle. When you are extending the circle, in this case the image is formed here and the circle is extended in this direction. So radius of curvature is taken as positive. If the image is formed here, R1 is taken as positive. And if we extend this, we will get R2. If the image is formed here, then R2 is taken as positive and R1 is taken as negative. But the image is formed here, that is the reason why R2 is taken as negative. And one more point, for convex lens, the focal length is always positive. For convex lens, the focal length is always taken as positive, and for concave lens, the focal length is always taken as negative. For convex lens, the focal length is always taken as positive, and for concave lens, the focal length is always taken as negative. These are the sign conventions that are to be followed. And we have two formulas. One is lens formula, 1 by f is equal to 1 by v minus 1 by u. And another one is lens maker formula, 1 by f is equal to n minus 1 into 1 by r1 minus 1 by r2. By using lens formula, we can calculate the focal length, and by using lens maker's formula also, we can calculate the focal length. The difference between that and this is, here we consider bifocal lens, there we consider a single piece of lens. And sign conventions are very important. And one more thing, when the real image is formed, the u is always negative. When the virtual image is formed, u is always positive. When the real image is formed, R1 is always positive. When the virtual image is formed, R2 is always positive. This is what I have concluded by referring many books. Thank you.